You should also be able to see my screen now, and I'll turn my video off. Yeah, we'll get cracking with the hour. So, general layout for the next hour or so. I think it's always nice to take a bit of a step back and ask what we're doing, why are we here, what are we trying to achieve with all this stuff. Everybody's obviously maybe familiar with certain LCA terms or looking into using LCA tools themselves. But before we get stuck into the nitty-gritty of the demonstration, I think it's a good idea to take a bit of a step back and have a quick reminder of what we're actually trying to achieve with all this stuff. I'll then go through some LCA basics, I guess, or we call it, the industry calls it lifecycle assessment. eTool have coined the phrase lifecycle design because we really feel that LCA only captures the small part of the work. When it becomes really useful, a really powerful tool is when it's actually used to improve on the design outcomes, improve on the environmental performance, improve on the cost performance. And so lifecycle design, we feel, captures that general process a little bit more succinctly. I'll also chat through the BREEAM requirements for 2014 and 2018, and then I'll jump into the software and provide a very quick overview of the key functional pieces of the tool. And we will be following this up with another more detailed webinar, detailed software demonstration, and in that next webinar I'll run through how to actually model a building from start to finish. The aim is to get that in under an hour, so a bit of a whistle-stop tour of building a model, but it will give you a more deeper flavour of what's involved in building your own LCA tools. So this first run, general introduction to LCA, and then encourage you all to come along to the next detailed session in I think a couple of weeks. I've got the next one, and we can look deeper into the software. Anyway, let's crack on. So why improve? Why do we want to improve on what we're doing generally in the building industry, in the sustainability industry? There's kind of four motivations that our clients tend to come to us with. One is regulatory, making sure you're ticking the right boxes. Maybe there's BREEAM requirement for planning, and LCA could form a part of that. Some councils now are requiring LCA to be done or allowing LCA to be done in lieu of other regulatory requirements. The London Plan mentions embodied carbon, and certain end clients or the landowners will also require LCA or embodied carbon assessments to be completed. Another motivation is to reduce costs. Our LCA modelling goes hand in hand with LCC modelling, and quite often a reduction in an improvement in environmental performance also results in a improvement in cost performance. And factoring in all these cost fluctuations over the life cycle of the building can be a really powerful tool for the end user, for the tenant or the occupant. Some of our clients just want to remain competitive. They're seeing that everybody else out there is getting involved in this stuff, and they want to do it too. And if you look at some of the other trends in clean technologies, solar PV, big rise in the number of installations over the years, and part of that is just down to people seeing that everyone else is doing it and jumping on that kind of bandwagon. And then you get the really nice clients who genuinely just want the best environmental outcome for their project. They have targets, perhaps, that they want to meet in terms of continuous improvement in sustainability, and they want to present a good story that they're doing the right thing. Generally, there might be a mixture of all these different motivations, but it's important to understand at the beginning what the client's motivation is. And then you can phrase the LCA modelling and the reporting that you produce at the end. We have a lot of automated reports. If it's LCC that they're more interested in, then obviously running the LCC report. If it's purely to tick the BREEAM box, then presenting the automated BREEAM reporting. If they want to present a nice fluffy message around what they're doing, then we have some more presentable reports, I suppose, that might be more amenable to end users and occupants. So what's the problem that we're faced with today? It's the biggest environmental burden at the moment is quite clearly climate change. And here it is in a nutshell. You have the kilograms of carbon on a tons per person per year basis there. You have the current global average is about 7 or 8 tons per person per year. America, Australia, pretty high there at 25, 30 tons per person per year. Europe a little bit lower, 15 odd tons per person per year, but that's completely unsustainable and causing catastrophic climate change events that we hear about year in, year out. So what's sustainable level? IPCC have defined it, come out with a sustainable target of about 1 ton per person per year, or 80% reduction on what we're doing at the moment. And yeah, what that means for me and you sat here is that we need to get our emissions down from about 15 tons each to 1 ton each. Obviously, as we continue to bellow out carbon at unsustainable levels and the population also continues to increase, our personal carbon budget becomes smaller. Not quite zero, not yet, may need to be, depending on how we progress in the next 10 years, but the planet does have an ability to sustain a certain level of carbon, but it's significantly lower, obviously, than what we're doing at the moment. Where do buildings fit in all this? Here's a Sankey diagram of the carbon economy, or the greenhouse gas economy, your climate change gases, greenhouse gases causing climate change on the right there, CO2, methane, and nitrous oxide. Then on the left, you have your sources of those gases. So you have transport, you have electricity and heat, you have industrial uses, land use change, agriculture, and waste. And when we think about buildings within all of that, you have about 15% of the total directly attributed to running and operating our buildings, the electricity and heat that they're using. But all these other factors come into play at some stage over the building's life. We have to transport people and materials around to build and maintain the building. We have to manufacture those materials in the first place. You see cement and steel there, pretty significant, over 5%, 6% of the total. So, and vast majority of that going into the construction industry, steel, also the automotive industry somewhat, but yeah, a big chunk of materials there going into this climate change problem. And actually, when you think about what's regulated, commercial buildings, we're regulating their energy consumption primarily to tackle climate change. Actually, the materials down here are just as significant, more significant than that, and will no doubt be regulated at some stage in the future. As we're seeing LCA regulation kind of grow and the interest in it grow, and the BREEAM criteria expanding on LCA. Land use change, there might be some land use change depending on the types of materials that you use, particularly timber. And then nothing lasts forever. Some things will end up in landfill or waste recycling plants, and there'll be some fairly small, but some impacts there. So overall, you're talking about more like 30–40% of the greenhouse gas problem is directly or indirectly related to buildings and infrastructure. Thinking back to that 1 ton per person per year target, we can think about where buildings might sit within that target. We need to leave space within our carbon budget for eating, for buying the sort of stuff that we like to buy, or getting rid of it, for transport, etc. And so we can get our house building and our work building and think about the target per occupant of those buildings. It comes to probably about 0.1, 0.2 tons per person per year. If I come on a project and I can get them down to that, then I'm pretty happy that it's a sustainable building. Anything over that is probably is not sustainable. It's over the target that we need to be aiming for to manage climate change. It's pretty ambitious, and the rest of the carbon economy is pretty ambitious as well. That food at 0.3 tons assumes a vegetarian, fairly unprocessed diet. Transport at 0.05 tons, going everywhere by bicycle and public transport. Our timber frame house, completely renewably run, and can get down to 0.1, 0.2 tons per person per year. But yeah, long way to go, but certainly when you break it down in terms of what these targets are and where we need to get to, we can then track our progress of how we're getting there. Are my choices sustainable? So here's a small example of the power of LCA. So when I came over here a couple of years ago now to set up the UK office, I was looking for a laptop stand, and I saw this timber stand, and it had all these eco credentials, and it looked very good, made from timber, but I couldn't find a local source for this particular product. This one was being shipped from Canada, I think it was, and there was no one making this one locally or even in the UK at the time. I wasn't sure if that's the right decision. Maybe it's better to go for a standard laptop stand that is made locally from plastic. So I dropped it into the tool, and here are the results. We had a product stage to make this laptop stand, the plastic and the manufacturing processes involved to make the stand, about 6.5 kilograms of CO2 equivalent. Transport stage, transporting this product to the building, to myself where I'm using it. Pretty small, it's not come very far from the plant. And then end of life stage, so eventually after 5-10 years, this will become non-functional. The laptop stand will break eventually. Things, little screws or springs in it might wear out, and it will break, and we'll probably throw it in the bin on average. As an average person, and throw it in the bin, and there'll be some end of life impacts there. Pretty negligible. The plastic just sits in the landfill site, and very negligible in terms of CO2. A lot of buzz at the moment around plastic, I might add, and some of its other impacts, ecotoxicity impacts or marine impacts. These are things that can also be measured in the LCA, but this particular study here is focused primarily on CO2. So how does that compare to the timber stand? Well, the timber stand, we actually have a negative impact at the product stage. So -2 kilograms, we get a credit for creating demand for this timber. Creating demand for this timber product means that we need to grow more trees, and those trees sequester, they absorb carbon out of the atmosphere, and that gets locked into this product essentially, and we get a credit for that at the product stage. At the transport stage, yeah, it's significantly higher, being shipped from overseas, and that's as we'd expect. And then we have the end of life impacts. And so if this product breaks, although there's less moving parts, so it's probably likely that it's going to last a bit longer. This product breaks and it ends up in landfill. Then all that carbon that was locked in out of the atmosphere gets released as the product breaks down in landfill, released in the form of methane and CO2 and quite pokey greenhouse gases. So quite significant impacts at end of life there, but we see overall that this timber stand is the most sustainable product. And through this LCA sort of process, we've got some good learning outcomes. So we know that, okay, transport's important as expected, but actually what's more important is what we do with this stand at the end of its life. If we can combust it for heat or reuse it in some way, we can get those end of life impacts down significantly, and we have almost a carbon neutral or a carbon positive result there. Our act of buying this stand has actually had a positive contribution to the climate change problem. So likewise for a building, unless we're assessing every stage of the building's life cycle, we don't really know if we're making truly sustainable choices. So yeah, we have the material stage, extracting materials from the ground, transporting them to a plant. They get manufactured into useful products. They then get transported to the site. They get there's various people and equipment impacts associated with putting these products together into a useful building or asset. Then we have to run the building. There's operational water and electricity and heat to run the building and keep it comfortable and functional for its occupants. We also be various maintenance impacts. We have to clean the building. We'll have to replace various elements. We'll have to repaint it, relay carpets, all these things that don't quite last the life cycle of the asset. Then there'll be disposal impacts, and they might end up in recycling, or it might end up in landfill, and there'll be impacts there that we should be assessing and making informed decisions based on the total life cycle impacts of this building. That's, I guess, the embodied carbon or the side of the story. One other crucial thing that often gets pressed over a little bit too quickly, in my opinion, is the functional unit. How do we compare two different designs with the same end product? So here's a good example of a coffee machine. You have your bog standard, cheap plastic coffee machine on the left there, very lightweight, low in embodied cost, low in embodied energy, low in embodied carbon. Compare that to the one on the right. Lots of steel manufacturing processes gone on to make this thing very high in initial embodied carbon. And that's not a fair comparison. We want to be breaking it down in terms of, okay, what's the purpose of these machines? The purpose of them is to make cups of coffee. We want to be thinking about what the impacts are per cup of coffee. The one on the left is probably going to make 200 cups of coffee over its life. The one on the right is going to make something like 200 cups of coffee every day. So we want to be thinking about kilograms of CO2 per cup of coffee made, or pounds per cup of coffee made. And that's why professionals will be using the one on the right, because it's much cheaper. Although initially very expensive, much cheaper over the life cycle, and the same applies for a building. You know, we could have the most very sustainable building, but if we only put one person in it, it's not a good use of resources, and there can be some much better wins when we think about how can we extend the functionality of this building, increase the number of occupants, increase the life expectancy of the building, and strategies around that. So as explained, we look at multiple impact categories. CO2 is obviously the biggest environmental burden at the moment, but we also, through the LCA, can measure water, can measure acidification, eutrophication, ecotoxicity, ozone, a whole host of different environmental indicators, and cost as well, which we just treat as another indicator. It's not an environmental indicator, but it is another indicator that we can measure and review and present strategies against. Often, the reductions in CO2 can result in reductions in cost or reductions in these other environmental indicators, but not always. Sometimes there's trade-offs over the life cycle of the building. It's important to recognize those and assess the viability of your strategies, your design strategies, against each one. Generally, I would say reductions in CO2 does create a reduction in almost all the other indicators. But not always, something like PV has very high ozone impacts from the manufacture of the panels. It doesn't save that much ozone over the life cycle from the reduction in electricity. Timber we saw is very good in terms of CO2, but not so great in terms of land use. So if land use becomes a big environmental problem in the coming years, then suddenly we need to rethink the timber strategy and whether that's the best thing for us globally. Design versus rating. So everyone's probably very familiar with the idea that the earlier you get involved in the design process, the greater your ability to influence change and improve on the environmental performance of the final outcome. And we recognize this from the very beginning when we established eTool and the software, and we've really targeted some functionality that I'll show you shortly that allows you to really get engaged early on, put together some rough and ready models, model templates, make some high-level assumptions, and start engaging with the design team and talking about what you can be doing to improve on the design. I think traditionally, people were hanging around, LCA practitioners, till sort of pre-construction or later design stages when they had lots of detailed information to model and can start to think about alternative materials and comparing specific carpet types and EPDs and things like this. But but that's missed out on a whole host of potential savings that could be making. So yeah, super engaged about getting involved early on, stage 2 or even before stage 2, and start chatting about LCA and what we can do to improve things. We get involved in a host of projects, but doesn't matter whether it's infrastructure, rail, road, master planning, commercial, office, residential, whole development-wide projects. Yeah, you can model basically anything in the built form in eTool. And that brings us back to our 1 ton per person per year target. And I'll always have that in the back of my head when I'm running LCAs, either on a consulting basis or checking people's models and helping them in their software. How close are you to this 1 ton per person per year target? They might have an office project that's sort of 7 tons per occupant, and they have a residential house that's 4 tons per occupant, and yeah, it gives you a big picture of where we're at and what we need to do to try and get to this sustainable dream. Little note on the eTool journey. So we established back in 2011. 2 guys, renewables engineer, and Rich, who wrote software safety systems in the mining sector. And they got together, realized that there wasn't really much out there doing LCA on a building level, and established eTool. Completed our first commercial job, and everything branched off from there. I joined them in 2013. I was focused in their consulting team. So as well as providing software, we can also get involved on a consulting basis and just run projects for the design team, provide the results and the feedback. But what we get super engaged and super pumped about is when people come on and join the eTool community and learn how to run the LCA model themselves, and we all feedback and learn and improve on what we're doing. We had the standard released around 2014, 15978, and eTool was brought up to that standard with a few tweaks around 2014. Then we had BREEAM Impact coming. We've currently got about 3,000 registered users globally. We've got, and the big one for us, mid-2016, we hit 500,000 tons of CO2 avoided over the design life of the buildings modeled in eTool. And yeah, we're really pumped about that. it means that what we've built is actually improving things. We're primarily passionate about this climate change issue, and yeah, the people that are using our tool to actually improve on what they're doing, which is what it's all about. We see very little point in assessing a building if it's not going to at least contribute to some learning outcomes and hopefully some improved environmental performance on the building. What's coming up next? Actually, this is already in place now, which I'll show you shortly, is the 15686 compliant lifecycle costs reporting. So we can report against the MAN 2 credits and have a more detailed lifecycle cost modeling that we can now do. BIM integration also well on its way, having a plug-in to things like Revit and linking the LCA model to BIM packages. A bit of a word of warning, I suppose, about that is that it is a kind of poison chalice in some ways. The BIM industry is still in its infancy. It's very rare that we come across a BIM model that is complete to enable you to complete a full LCA. You know, it might show the area of the floor, and you might be able to assume some carpets, but we won't be sticking in the glue and the carpet underlay that goes into that BIM model, that goes into the LCA. And these can be very important factors that contribute to the results, and are not captured always in BIM unless you've got a very high quality BIM team. What's more, very rare in BIM that you're going to capture the trade and the maintenance and the cleaning and the equipment, the concrete pumps, the cranes that are used for all these materials. So yeah, BIM only gives you sort of part of the information, I suppose. There's still a lot of work to do, and to get an LCA model complete. And then on top of that, you also have errors in the BIM model. So you might have a column, a steel column, and there's sort of slight gaps in the column that mean that it's hollow when actually it was a solid steel column. Or, you know, little examples like that can really throw out the results. So it's something to definitely watch out for. We'll show you how we tackle our LCAs in a much more efficient manner shortly. So rating systems, a lot of interest in this at the moment, particularly with BREEAM 2018 coming out. But yeah, you can use eTool and LCA to award credits in BREEAM infrastructure, in LEED, 3%, in fit out, up to 7%, in international 7%. This is of the total available, so pretty significant. At the moment, in BREEAM, you get in BREEAM 2014 and 2011, you get 2% of the total available credits for running an LCA. That's in addition to the normal Green Guide credits that you're probably awarding. And in 2018, that's being scrapped, and we jump up to 10%. No more Green Guide, all LCA approach, and I'll just chat about that in a bit more detail now. So you get up to 10 credits for doing an LCA. 2 of those credits, you model the LCA, you model the building, and you compare it against the BRE benchmark. And if it's an average building, you might get, you know, half a credit, a credit. If it's a really good building, then you might get up to 2 credits. Then we have the rest of the credits, which is all around optioneering and appraisals and engaging with the design team. And so you get up to 4 credits for modeling superstructure options, you know, alternative window systems, floor systems, roofing, foundation, roofing. And if you model some options at stages 2 and stages 4, then you get the full 4 credits there. You get 1 credit for modeling options on substructure at stage 2. You get 1 exemplary credit for modeling services at stage 2. You then get another credit for alignment with lifecycle costing, and a credit for third-party verification. And I was pretty encouraged by the way that BRE have set this up. We did consult on them quite a bit over the past year, and it's very much followed the general modeling process that eTool have maintained for the last 8 years, whereby we're getting involved early as possible, putting together a rough model and presenting some options, refining that model as we go along, looking at some more detailed component level analysis at stage 4. Maybe, when the client's interested, looking at costs alongside this. And as standard for eTool and all our users, we complete a third-party verification on, and that's included in everyone's software packages, and we think is a really important aspect of LCA work at the moment, to improve the quality of what everyone's doing, improve their assumptions, and learn from each other. You know, that we can get a bit more, should I say, confidence in LCA and the results that are coming out of it. So yeah, big updates in BREEAM 2018. We have had quite a lot of clients who are actually transferring to BREEAM 2018 simply because they're running their LCAs, and it's easier to meet their target in BREEAM 2018 than it was in 2014, which is often not the way. I think it normally gets harder. But if you're engaged in LCA or trained up in LCA, then it could be much easier. Yeah, so that's BREEAM 2018. Whilst we're on that, I'll just see if anyone has any questions. We are the only ones, I think, that are fully prepared for BREEAM 2018 with our third-party verification, alignment, template system that allows us to get in there early and produce models very early. Okay, cool. No questions there. Hopefully that's clear to anyone, but do get in touch if you have any specific questions about 2018. As I said, we have been quite engaged with BRE in this credit offering, so we're fully aware of the requirements and what needs to be reported to achieve the maximum credit. Here's a quick example. So Interserve's flagship head office, at the time they were calling it Project Beagle. Forget what they call it now. It has changed its name to something else flashy. This is, it was 13,500 meters squared office. We came onto this job on a consulting basis, so we took the specs, ran the model, and provided the results to the team. Alternatively, we could have trained them up to run the model themselves, or trained up a consultant that was involved to run the model themselves. But yeah, we did this on a consulting basis. We charged about $7.5K for the LCA. In terms of modeling time, to model the actual building, I'd say it was about 2 days in eTool, grabbing information, reviewing it, and matching it up to our template system. The BREEAM assessor was very happy. They got their 2 bonus innovation credits. The design team was very happy. We were looking at some specific recommendations around the concrete mixes. What can they do? They were getting their steel from Tata Steel, and what was the difference in impacts of that against the average industry average data that we have on steel. Lots of interesting learning outcomes that were coming from it as well. And although we came in quite late, it was still a very beneficial process for the design team to begin to understand and engage with LCA and take forward in future projects. Just as a comparison, they spent over 3K to install the 60 bag cracks, and they get 1 transport credit for that. Not entirely our place to say which one's more beneficial overall for the planet. I'm definitely biased on that front. But just breaking it down purely from a cost per credit point of view, LCA really, if you're looking at anything over excellent, outstanding, really is worthwhile looking at LCA in a bit more detail as a strategy, as a cost-effective strategy for meeting your BREEAM targets. That was in 2014. Now with 2018 coming up, the 10 credits, it almost becomes a no-brainer really if they're purely motivated by the costs that they're spending to reach their target. Evidence criteria, quite straightforward. BRE are really trying to encourage at the moment people to just get in and produce some models. So they're just asking for a copy of the model that we send to the BRE and we clone into the BRE account, and a qualitative statement describing how the LCA did or did not impact on the design. Quite important there that you don't have to show that it's made some significant benefit to the overall design. It's always nicer, of course, if it does, but yeah, just have to say, look, we did an LCA and it was interesting because of this, but unfortunately we did not manage to influence any changes, or we did actually end up changing this, and this. So yeah, quite straightforward, and we have, of course, these templates automated from the tool that report against both of these criteria. List of our clients here, fairly old list at the moment actually. We've got a few more since I made this up. What's nice is that we're involved, we've got quite a unique business model, so we can really get engaged with any size of project and any size of company, whether you're a big consultant looking at doing lots of big projects a year and then maybe an annual type fee, or you're a small consultant and you only do a couple of little projects a year, where you would probably not go for the annual fee, you would go for a per project fee. And that allows us really to engage with any type of project, big or small, and really important, we feel, to be able to offer that, because yeah, you've got the big projects that maybe can afford to run LCAs, but they're only a small part of the overall construction industry. The vast majority of construction globally is small and medium-sized projects. So if we can get LCA running on them as well as the big projects, then we'll be really on top of the battle to improve our environmental impacts of built form. Okay, so yeah, general overview of eTool and where we're coming from. Hopefully you found that interesting. I'm going to quickly jump into the software now. eToolLCD.com. You can register at this address for an open use account, and you'll have full access to what you see here. You'll have access to our OzLCI data set, and we have various other data sets that are stored in the back end that you won't have access to, but in terms of the functionality, you'll have full access to the tools. They're great for having a little play around and a little test for yourselves over how you feel about the software. So let's jump into escape here. Yeah, there we go. So yeah, web-based platform, and you see here a list of my projects. I'm just going to jump in quickly to a blank base design. And we see here the general layout of the tool. We have our people and equipment impacts to come and build and maintain the building. We have the materials impacts, the substructure, the superstructure, the finishes, fittings, services, etc. Then we have the energy and the water used to run the building. On the right here you see the same information, 0.0165 kilograms of CO2, but presented in life cycle terms, so the product stage, transport stage, construction stage, recurring, so the maintenance impacts essentially and replacement impacts the various materials, energy, water, and end of life there. We can look at CO2, we can jump into any of these other environmental indicators, and we see the impacts now in terms of CFC 11. We can look at pounds, and we see the impacts in terms of pounds. I'll give it a second to load. It's sometimes a little bit slow when I'm on the webinar here. Generally, wouldn't expect it to be. Ooh. Just to refresh that. Click back into pounds again. There we go. So, yeah, generally a quick refresh fixes any of the little delays that you get. So now we're looking at pounds per meter squared per year. We can look at absolute terms, or per occupant per year. We can adjust what functional unit we use to measure against. I'll go back into carbon, which is what we're all more familiar with. And let's take a look at building the actual model. So it's looking pretty empty at the moment. All we have in there is 1,000 meters squared of roof membrane. And I'll just click into that to show you where all these results come from. You have all these variables for each material, the density, the quantity, the life expectancy, construction waste factor, transport distances, and these all influence the overall results, overall cost results, overall CO2 results, and all the data entries for each material are held in the back end of behind the scenes of the tool. We select our material, and we get a lot of default figures here, populated by default in terms of life expectancy. These are all held in the data set. Transport distances, density, and yeah, we have the ability to update these if we so wish. So generally, obviously the most important one is the actual quantity. You want to make sure that that's accurate. Generally, I'd leave all the rest of these as defaults, but we do have the ability to go in and put in manual distances if we know it's come locally, or we can update the waste factor if it's maybe a unitized system or modular, might have less waste factors in there. Maybe there's a guarantee that means we can increase the life expectancy. Lots of different ways to play around with the data and think about recommendations and options going forward. But yeah, selecting the material and the quantity would be your first step. But all we have here is this membrane, and obviously adding every material in element by element like this would take far too long, and that's just the materials. Somebody's got to come and lay this bitumen roof membrane. Somebody might have to maintain it, and there might be some equipment that they use as well. And all those impacts need to be captured, and obviously if we were to do this element by element, we'd be talking about thousands of data entries, and nobody would be doing LCAs. It would take far too long, and we wouldn't be making any progress towards reducing our life cycle impacts. So what we've done is built a template library, and in this library we have hosts of thousands of, well over a few hundred, coming up to probably 1,000 now, templates, where we've averaged material quantities, man hours, equipment hours to build these different construction elements. So in this case, I'm looking for a whole roof system, and we see different makeups here of roof systems. Macadam layer there, concrete deck, insulation, ceiling finish. We have metal deck, lightweight planks there. That's one with a bitumen layer in, so let's just add that in for the sake of argument. And I'm putting 1,000 meters squared there. Now we see all of these other crucial materials have been added in. and they all have quite small impacts. I might present the results in absolute terms just to see which ones are more significant. Let's go to absolute here. We see also some equipment impacts have been added here and some people, and I'll jump into those quickly. And in this case, it's the roof structure, concrete pump to pour this roof, and a crane for these concrete planks that are also included. We also have the people and the various man hours to install the ceiling framing, the plasterboard, the insulation, the paint, and the most significant one there is the paint finish there. We see that the assumption is that it's repainted every 5 years, and that all adds up to some fairly significant impacts in terms of CO2, but especially in terms of cost. We'll click back onto cost here, and we see what this is costing over the life cycle of these people to come and build, and particularly to repaint and maintain this roof. Jumping into the materials there, internal finishes, fairly small compared to the overall superstructure. We look at the big ticket items there. We can see the concrete planks here, very significant precast concrete planks in this roof structure, and we see the insulation there is also fairly significant. So that's the template system. It really is a case of taking the quantities in terms of this is your area of floor, this is the specification, this is your area of windows, this is your area of wall, matching that up to its library, template in the library, and you've got your LCA generally. What we also have is the ability to obviously adjust these templates. So you might find something, generally you'll find something that very closely matches what you're looking for. There might be differences that you want to understand. So you'd go to the template library and you'd find the nearest one. I'll just search here, roof system. And you might have one here where you want to adjust the thickness of insulation or the thickness of the slab or the makeup of the roof in some way that looks significantly different to what we have here. So you can jump into the template, you can make a copy of it, and then you can make the update. And you might be, swapping out EPS, make a copy here, clone, and you might swap out EPS insulation for glass fiber insulation, or put a double layer of plasterboard in the ceiling, or whatever change that you might make. The template's built of sub-templates. It's very simple to adjust, thicknesses of insulation or quantities of materials, or add and subtract different sub-templates within the system. So we actually have whole building templates for particularly useful at that stage 2 modeling. I'll just search for a whole building. Here we go, office whole building. So this is a combination of templates for a whole building office, 14,000 meters squared, including bodies and operational impacts. So stage 2, I might just chuck in this worst case of concrete structured office, and we might have 20,000 meters squared of office. I throw that together and we see we've got some populated results here. We can jump into this office template and we can see the breakdown of all the different materials that go into this. Here's that roof system that we added earlier, and here's the whole building. So there's framing, there's wall structures, there's staircases, there's doors, all averaged on a per meter squared basis, but great to get in front of people early on and start discussing what can you be doing and talking about to improve on the impacts, looking at alternative materials, alternative systems that might be in place, and just get people sat around a table and looking at what the results are and what's important and what's not so important to focus their attention on. Then, as you get this information through, you can update with the specific templates and the specific quantities, whether that's from a cost plan, from a BIM model. We do also have this import tab, where rather than matching up the templates, we import the makeups from a CSV file, and we can then match them up in the model. So that's quite a useful feature if you have a cost plan or some outputs from a BIM model that you want to import. You can do that here, but I think it's important to understand the template system and how that works. So if nobody has any questions there, let me just double check. No? I'll jump into now reporting. So yeah, as I say, the life cycle assessment should be a small part of the overall works. What you really want to be doing is focusing on improving the design, looking at recommendations and what we can do to improve the environmental performance. So generally, I would make a copy of a baseline model, clone it, and then start running some recommendations on it. And here's a list of recommendations that have been added. The software will record changes that you make to the design. So in this case, we've added in some solar PV, and that's had some initial impacts in terms of CO2 of 3.39 kilograms per meter squared to manufacture and install these PV panels. But over 10 years and over the life cycle, it's more than made up for, and we have a negative overall impact. We can also check the costs, and we see what's happened with the cost of these PV, and overall 0.6% saving against the baseline. So we can start to strategize and prioritize these recommendations in terms of what's going to provide the greatest environmental benefit for the least amount of money spent. Obviously, what the quickest way to achieving these goals is to make sure that money is spent most effectively in improving the environmental performance. So yeah, the software will can make various suggestions as well. We can add collections of recommendations. We might have high cost recommendations, low cost residential recommendations, commercial recommendations, and you'll be provided with this kind of list that we can then go in and record the changes that get made. So a very powerful feature of eTool, and really allows us to start thinking about prioritizing our options and strategies. Once we've got that, we want to report the results, and we have a host of automated reports. See if I've got any saved here. Different ways of presenting the results, and I'll just show you the top impacts report. That's quite a nice little one. You can report against CO2 or acidification or costs, the top impacts, so ordered from highest to lowest, the total impacts of each material. And so again, thinking about where to prioritize our efforts, obviously if we can find alternatives or look at options around these ones nearer the top, then that's going to be a lot better than focusing on the smaller items at the bottom that are almost negligible. It's always a nice one to run. Just whilst I take any other questions, I'll run the design feedback report. So we can report, this is a detailed LCA report. We can compare against a base design. We can look at the improved design and present the overall results. I generate that. It'll take a little bit of time to that's pretty quick. Yeah, it's pretty quick now. So some automated reports. We're not a big fan of copying, pasting data into Excel, and then it goes into a report, and then there's a mistake, and you make the update, and you have to reformat it and reissue it, and this is a big suck on consultants' time. Being a consultant myself, I'm well aware of that, and so we automate everything as far as possible. All the reports out of eTool, everyone has full access to these, and yeah, you have your sort of general project details, overall results, savings that you've made, some of these recommendations that you've been modeling. What do they do in terms of CO2 or cost or eutrophication? Some project details there, some of the assumptions, the templates that have been used, overall scope, what's been included and not included in this particular model, environmental indicators that you've been measuring, and importantly here, some detail on the recommendations that you've run. So, and you can update these in the recommendations, this text here. But you'd often have, these are the considerations that you want to think about for solar PV. You want to make sure you've got some south-facing roof, what are the maintenance and impacts of it, motion sensors, what would that mean in terms of the specification and the design assumptions for each of these recommendations, and of course your improvement there. That these are making to the overall design. So yeah, nice little report there, the design feedback report, and great to issue to clients, and very quick and easy once you've run those recommendations on the model. Here's some nice graphs. So you have your kind of baseline model and your improved model, and what happens to that over the life cycle, and the different placement rates of different items. Looks like we have fairly similar tracking here, but it won't always look like that. Sometimes you'll have something major in your base design that you've taken out of your baseline, of your improved design, and you'll see these graphs, do some quite interesting things. We see a big replacement there at 20 years. We could dig in and back into the model and have a look at that. And again, here at 30 years, that's probably something like your windows being replaced, major item. So you think about strategies for maybe prolonging the life of those windows and getting that line more steady. Here's the top impacts in terms of life cycle stages, in terms of operational, in terms of materials. A few nice graphs to present to the team in terms of the overall results. I'll send through some examples of these. We've got 5 minutes left, and what I'll do is just chat very briefly about the yeah, I'll take any questions actually if anybody has any initially. On the tool, as I said, we've got a more detailed session coming up in a couple of weeks, so I'll try and build a model from start to finish. And but yeah, I'll chat briefly about costs. So our consulting costs, if you want to bring us on as consultants on your project, they range depending on the project size, yeah, as you saw there, that 13,000 was about 7.5K. They range from, I guess, 4K for a small project up to 10, maybe 15 for very large projects. That's our consulting. Our software fees are a mixture of per project fees and subscription fees. And I'll just explain that on our website here. I think search engine optimization is good, but it's not that good that it picks up on spelling mistakes. So we have most people come on as a consultant for their first project, and that costs about £30 a month, 3-month minimum sign up. And with that, you get these various benefits. You get full access to the tool and all the data sets for costing and for environmental performance for your LCA and LCCs. You get phone and email support at any time, and attendance at the training course, which is 1 full day, and we run that every sort of few months at the moment. Then some people will be doing 1 or 2 projects a year, and that's fine. But hopefully the interest mounts up, often does. After you've done the first one, you get a bit more confidence in offering it as a service, and you might want to jump up to the specialist. And the specialist we've actually just revised. That's a single fee for the user, about £4,300 per user, and they get unlimited number of projects that they can run the LCAs on with no per project fees. Just to explain what else is included in the per project fee, it's not just a flat fee to cover the software, it also covers our certification service, that third-party verification that we do on everyone that's using the software commercially. Whenever you're presenting results to end clients, we see that it'll be mentioned that eTool has been used, or it'll have an eTool stamp on the reports, or you'll be using these automated reports. And we want to make sure that there's a certain level of quality being maintained in terms of the results and the assumptions and your LCA work. So we complete a detailed review of your model for each project. There's up to 6 models that we can review and provide feedback and engage with you in helping improve both the overall quality, but also look at recommendations or different ways you could do the modeling, make sure you're using the tool as effectively and as efficiently as possible. So that's all wrapped into the certification fees. And that very neatly brings us up to, I've got 5 past there actually, my clock was a bit slow, I thought we were coming up to 1 o'clock. Does anybody have any questions on that? The next the detailed webinar is another hour session that's coming up in a couple of weeks. We also have a training session, a whole day's training session, like I said, available to any of our consultant subscribers. So even if you don't have a specific project as yet, it's worthwhile subscribing just to come along to the training and learn a bit more about LCA. It's a 3-month minimum sign up, so £90 is for the training day alone is quite good value, I think. And hopefully then you start to think about how it can be used in your projects. We also have a lot of resources that you are welcome to check out. Our help pages, please do jump online, etoolLCD.com, and have a play around with the software. Follow some of the online videos and tutorials, come along to the next webinar or the next training, and other than that, thanks for listening, and look forward to tackling some LCAs with you in the near future. We've got one question come in from Daria. How much information do you need to have at hand to work with eTool templates? It's a good idea to have a look at the template library. What I would tend to do is get the areas of the various elements, whether that's from the cost plan or a model, or maybe even just measuring off the drawings. Sometimes quicker and easier. It doesn't need to be precise to get a decent LCA result. Make some estimates on the floor areas and the wall areas and the window areas. And then generally I would set up a spreadsheet. We can send this to you. We have this available on our website, and I just fill out a bit of data. The modeling process itself, very efficient and easy as long as you've organized the information in an effective way. So this is the tool, the spreadsheet that I sort of gather information requirements, and I might send this out to an architect if I'm feeling like the architect's generous and they're likely to be engaged enough to fill this out themselves. Or I'll give them a call and give the structural engineer a call, just say, look, how deep are the piles going, what's the diameter on average. Stage 2, they'll give you some very rough figures, and at stage 4 you'll have a bit more detail, a specific piling schedule that you might look at. Concrete slab, reinforced, it's all about what information you have available. You don't need to wait. I strongly advise against waiting around for information. Go off what you have and fill in some assumptions and refine it as you go. And you bring the model up in a design team meeting, and they'll say, actually, we're using slightly different columns, or they're steel columns instead of concrete. And you go, yeah, that's fine. That's what the whole process is about, is engaging them early, running off some assumptions, whatever information you have available as the design progresses, then updating the model with more detailed specs and information. Nobody's going to know at stage 2 what thickness and type of insulation they're using at the walls, because they need to wait for the energy modeling to be complete. And that doesn't really happen until they know the full specs. So it's about getting involved early and using what you have available to you. Got some rough drawings, make some assumptions, and drop some templates in and refine as you go along. Better to do that and capture some LCA learning as soon as possible than sit and wait around until stage 4 when you have all this detailed information that will produce a very detailed model, but probably only be a little bit more accurate. That's the general message, I guess. Better to have something vague than have nothing at all. Something vague early on than have nothing at all, and might be waiting until it's too late to really influence things. Hopefully that answers your question, Daria. If anyone else has any questions, feel free to pipe up. Otherwise, thanks very much for listening. I'll let you get on with the rest of your days, and look forward to chatting to you soon. Thanks everyone.